Okay, so this exercise is just an optimization problem. That is, here we have to find the maximum value of the function f equal to y squared minus x squared plus 22 on the region D defined by x squared plus y squared less than or equal to 100. That is the disk with center the origin and radius 10. Okay, now how can we find the maximum of this function on this region? Well, step 1, we find the critical points of f. That is, we are going to compute the gradient of f. Now, the gradient of f is negative 2x, comma, negative 2x, comma, 2y. Perfect. This guy here is equal to the zero vector if and only if x is equal to y equal to 0. So the only critical point of f is the origin 0, 0. Perfect. Now, let's try to understand the nature of this critical point. To do this, we are going to compute the second derivatives of f. That is, the second derivative of f with respect to x, which is negative 2. The second mixed partial derivative, this one is 0. The second partial derivative with respect to y is 2. Perfect. Now, let's compute the determinant of this matrix. Okay, the determinant of this matrix here is equal to what? Well, we are going to have negative 2 multiplied by 2, which is negative 4, less than 0. So, this one is a saddle point. Perfect. This shows that the maximum of this function is going to be achieved on the boundary of this disk, that is, on the circle with center the origin and radius 10. Now, the equation of this circle is x squared plus y squared equal to 10 squared. Perfect. This shows that x squared is equal to 10 squared minus y squared. Now let's plug this value of x squared into this equation. So what do we get? We get f of y only. Well, this one is y squared plus y squared minus 10 squared plus 22. So 2y squared, okay, 2y squared minus 100 plus 22, so minus 78. Perfect. Okay. Now let's find the derivative of this function. Well, the derivative is for y only. Perfect. And this is equal to 0 if and only if y is equal to 0. Perfect. Okay. Now, if y is equal to 0, what do we get? We get x equal to positive or negative 10. So we have two critical points of this function. Just for the sake of notation, let me call it g of y. So we are not going to confuse this function of one variable with this function of two variables. Okay, now the critical points of g on the circle x squared plus y squared equal to 10 squared are given by negative 10, 0, 10, 0. Okay, now let's evaluate f at these two critical points. Well, here, what are we gonna have? Okay, we have f of negative 10, comma 0. Okay, f of negative 10, comma 0 This one is negative 100 plus 22. This is the same as f of 10 comma 0. Perfect. So 78. Okay, 78. Perfect. This shows that the maximum of our function on our circle is 78. Actually, our function f is constant on the circle. So the maximum temperature on the disk is 78, and we are done.